Welcome to lecture 4 of sum of two independent random variables. So we'll continue with more number of questions on sum of two independent random variables. Question is the random variable x has the probability density function c into 7 minus x for all x between 0 and 7 and is 0 otherwise. So the random variable x as the probability density function, that means fx of x as equal to c into 7 minus x for all x between 0 and 7 and 0 otherwise. The random variable y is independent of x and is uniformly distributed between 0 and 7. So x and y are independent random variables and the random variable y is uniformly distributed between 0 and 7. So the probability density function of y, fy of y will be equal to 1 divided by 7 minus 0 for all y values between 0 and 7. That means it is 1 by 7 for all y values between 0 and 7 and it is 0 for other y values. Question is find the value of c and then find the probability density function of the sum w, where w is the sum of x and y, sum of two independent random variables x and y. First we shall find c. So as per the question, fx of x and fy of y, probability density function of the two independent random variables x and y are given in the question. Now we need to find c. Since fx of x is a probability density function, integral from minus infinity to plus infinity fx of x dx must be equal to 1. So integral from minus infinity to plus infinity fx of x, but fx of x is c into 7 minus x between 0 to 7. And it is 0 for all other x values. So you consider that x values only between 0 and 7, because for other x values this fx of x will be 0. So take integral 0 to 7 fx of x dx, which is c into 7 minus x dx, that must be equal to 1. Keeping c outside the integral sign, integral 0 to 7 minus x dx will be equal to 1. c into integration of 7 with respect to x is 7x minus integration of x with respect to x is x square by 2. Difference at the upper limit 7, lower limit 0. That must be equal to 1. So take the difference by putting x as 7. So it will be 7 into 7, 49 minus 7 square means 49 by 2. 49 minus 49 by 2 will be 49 by 2 minus putting x as 0 whole bracket is 0. So c into 49 by 2 minus 0 will be equal to 1, or c will be 2 divided by 49. So whenever it is said that fx of x is a probability density function, a probability density function will always satisfy the condition minus infinity to plus infinity, that probability density function fx of x dx as equal to 1. So this condition can be used whenever we have to calculate some unknown factors, unknown constant c or k. So c value is calculated. Next is find the probability density function of the sum w. So substituting the value of c, fx of x will be 2 divided by 49 into 7 minus x for x between 0 and 7, and it is 0 for other x values. Now probability density function of w, that is fw of w, is the convolution of fx of x and fy of x, fy of y, which is given by the formula integral minus infinity to plus infinity fx of x into fy of w minus x dx. Here fx of x means 2 divided by 49 into 7 minus 6 for x values between 0 to 7, and it will be 0 for all other x values. So you take only that x values, integration is with respect to x, so take x values from 0 to 7, and in place of fx of x write 2 divided by 49 into 7 minus x. 2 divided by 49 can be kept outside the integral sign. So 2 by 49 into integral 0 to 7, 7 minus x into fy of w minus x dx. Now we need to find what is this fy of w minus x. So we look at that probability density function fy. Fy of x will be 1 by 7 for all, fy of y will be 1 by 7 for all y values between 0 and 7. So instead of y it is w minus x. So fy of w minus x will be 1 by 7 for all w minus x values between 0 and 7. And for remaining w minus x values other than 0 to 7, that fy of w minus x will be 0. So you take only that w minus x values between 0 and 7, so that this fy of w minus x will be 1 by 7. Now w minus x is greater than or equal to 0, less than or equal to 7. W minus x is greater than or equal to 0 means x should be less than or equal to w. W minus x is less than or equal to 7 means x should be greater than w minus 7. So from this we get x should be greater than w minus 7, less than or equal to w. And this w, which is the sum of x and y, x lies between 0 and 7, y also lies between 0 and 7, so the sum x plus y or w lies between 0 and 14. Integration is with respect to x here in order to find fw of w, and the interval for x is 0 to 7, interval of length 7. So what we'll do is these w values, we'll take it into sum of different subintervals of length 7. We'll start from 0, length 7 means up to 7. Then we'll take from 7 of length 7 means up to 14. So we'll split this interval for w, that is 0 to 14, into two subintervals, 0 to 7 and 7 to 14. So first case is w is greater than or equal to 0, less than or equal to 7. We need fw of w. For that we have to substitute fy of w minus x. And fy of w minus x will be 1 by 7 when w minus x is between 0 and 7. That means x is between w minus 7 and w. So now if I take w as between 0 and 7, when w is between 0 and 7, when w is 0, w minus 7 will be minus 7. When w is 7, w minus 7 will be 7 minus 7 or 0. So for this value of w between 0 and 7, w minus 7 will be between minus 7 and 0. Here the integral starts with the 0. X will be greater than or equal to w minus 7, and w minus 7 value lies between minus 7 and 0. If we take negative values, then x should be greater than or equal to this, but in the integral x starts with the 0. Interval for x is 0 to 7. So x cannot take negative values. In the lower bound of x, you take 0 itself. Upper bound, x should be less than or equal to w, and clearly w lies between 0 and 7. X should be less than or equal to w, and remember interval for x is 0 to 7. So x should be less than or equal to w holds. So upper limit will be w. So 2 by 49 into integral 0 to w 7 minus x 1 by 7 dx. 1 by 7 because of this fy of w minus x. So 2 by 49 into 1 by 7 means 2 by 343. Integral 0 to w 7 minus x dx. Integration of 7x is 7x minus integration of x is x square by 2. Difference at the upper limit w, lower limit 0. So 2 by 343 into, put x as w, 7w minus w square by 2 minus put x as 0, whole bracket will be 0. So 2 by 43 into 7w minus w square by 2 or 14w minus w square divided by 2. 2 cancels, so denominator will be 343, numerator 14w minus w square. Next, second case is we'll take w as greater than or equal to 7, less than or equal to 14. When a w lies between 7 and 14, w minus 7. When w is 7, w minus 7 will be 0. When w is 14, w minus 7 is 14 minus 7 or 7. So w minus 7 now lies between 0 and 7. And the interval for x is between 0 and 7. So x should be greater than or equal to that. And less than or equal to w. W lies between 7 and 14. So you take only 7 because greater than 7 not possible for x. So take the upper limit as 7. Lower limit as w minus 7 because w minus 7 lies between 0 and 7. So fw of w will be 2 by 49 into integral w minus 7 to 7 into 7 minus 6 into that fx of w minus fy of w minus x is 1 by 7 dx. 2 by 49 into 1 by 7 is 2 by 343. Integral 7 minus x from w minus 7 to 7 dx. Integrate. Integration of 7 with respect to x, 7x. Minus integral of x with respect to x is x square by 2. Difference at the upper limit x is equal to 7, x is equal to w minus 7. 2 by 343 into, put x as 7, 7 into 7 is 49, minus 7 square is 49 by 2, 49 minus 49 by 2 will be 49 by 2, minus, put x as w minus 7, 7 into w minus 7 minus w minus 7 whole square by 2. So 2 by 343 into 49 by 2 minus, multiply, minus 7w, minus 7 into minus 7 plus 49 and minus minus plus w minus 7 whole square by 2. So remaining is the simplification part. 2 by 343 into 49 by 2 minus 7w plus 49 half into, expand this, w square minus 14w plus 7 square means 49. Half into 49 is 49 by 2 plus 49 by 2 means 49. 49 plus 49 will be 98. Then minus 14w into half minus 7y and minus 7w into plus minus 7w which is minus 14w. Then half w square. So 2 by 343 into 98 minus 14w plus w square by 2 or multiply by 2. 1 by 343 into 2 into 98 is 196. 2 into minus 14w is minus 28w. 2 into w square by 2 means w square. We have the probability density function of the sum w equal to x plus y. Next question. A discrete random variable y as the probability density function fy of y is equal to 0.5 into delta y plus 0.5 into delta y minus 3. Y is a discrete random variable and its probability density function is expressed in terms of delta function. Now u is y1 plus y2 where y1 and y2, these y's are independent. So probability density function for these y's, y1 and y2 will be this. What is the probability density function of the sum u? Now for y1, probability density function is fy1 of y is 0.5 into delta of y plus 0.5 into delta of y minus 3. Similarly for y2, the probability density function fy2 of y is 0.5 into delta y plus 0.5 into delta of y minus 3. From this probability density function for y1 and y2 expressed in terms of unit delta function, we can identify y1 values. In that delta factors, treat it as a delta of y minus a. Whatever comes in place of a, that are y1 values. So here delta of y minus 0, delta of y minus 3. So the discrete values of the random variable y1 are 0 and 3. Similarly fy2 of y, probability density function of y2. Here delta of y minus 0, delta of y minus 3. So the discrete values of y2 are 0 and 3. U means it is the sum of y1 and y2. So the values of u are, possible values of u are y1 plus y2, 0 plus 0 is 0. 0 plus 3 or 3 plus 0 will be 3. Then 3 plus 3 is 6. So the possible values of u are 0, 3, 6, discrete values of u. Now probability, by looking at that probability density function of y1, we can write the probability of 0, probability of 3. Since y1 values are 0 and 3, the probability that y1 takes value 0 or probability that y1 takes value 3 can be written from this. So probability that y1 takes value 0 is 0.5. Probability that y1 takes value 3 is 0.5. Similarly y2 values are 0 and 3. Probability that y2 takes value 0 is 0.5. Probability that y2 takes value 3 is 0.5. So probability of 0 and 3 are 0.5 each. Since y1 and y2 are independent, probability of y1, the joint probability of y1 and y2 will be equal to probability of y1 into probability of y2. Now the question is, what is the PDF of u? Probability density function of u, fu of u will, since u is a discrete random variable whose discrete values are 0, 3, 6, we'll write the probability density function of u, fu of u, again in terms of delta function. For each of these possible u values, you should know the probability of u taking these values 0, probability that u will be equal to 3, probability that u will be equal to 6. Corresponding to these 3 u values, if you know their probabilities, then you can write the probability density function of u in terms of delta function. So first we will calculate it. Probability that y1 takes value 0 and y2 takes value 0 is equal to p of 0, 0 will be p of 0 into p of 0, which is 0.5 into 0.5, 0.25. Probability that y1 will be 0 and y2 will be 3. P of 0, 3 will be p of 0 into p of 3. 0.5 into 0.5, 0.25. Probability that y1 will be 3, y2 is 0. P of 3 comma 0 will be P of 3 into P of 0. 0.5 into 0.5 again 0.25. Probability that y1 will be 3, y2 will be 3. P of 3 comma 3, which is P of 3 into P of 3. 0.5 into 0.5, 0.25. Now the probability that u will be 0. Sum u will be 0 only when y1 and y2 both are zeros. Sum u will be 3 when y1 is 0, y2 is 3, or y1 is 3 and y2 is 0. The sum u will be 6 only when y1 and y2 both are equal to 3, because u is the sum y1 plus y2. Now we'll calculate each of the probabilities of u value. Probability that u will be 0. u0 is possible only when y1 and y2 both are zeros. So this probability P of u comma 0 is same as P of 0 comma 0, which is already calculated 0.25. Probability that u will be 3. u equal to 3 is possible when y1 is 0, y2 is 3, or y1 is 3, y2 is 0. So probability that u will be 3 is equal to P of 0 comma 3 plus P of 3 comma 0. 0.25 plus 0.25, 0.5. Probability that u will be 6. Sum will be 6 only when y1 and y2 both are equal to 3. So P of u equal to 6 is the same as P of 3 comma 3, or 0.25. So we have the probability of all these three discrete values of u. Therefore the probability density function of u, fu of u, is equal to 0.25 into delta of u minus 0 or delta u plus 0.5 into delta of u minus 3 plus 0.25 into delta of u minus 6. Next, the Gaussian random variable of mean mu x and variance sigma x square. So here we are considering a Gaussian random variable with the mean mu x, variance sigma x square, and that Gaussian random variable x has the probability density function fx of x is equal to 1 by sigma x into root 2 pi e power minus x minus mu x whole square divided by 2 sigma x square. This we have seen under normal or Gaussian random variable. Normal probability distribution, Gaussian probability distribution. The characteristic function of the random variable x is given by, x is a Gaussian random variable. So characteristic function of the Gaussian random variable x is given by phi x of j omega. It can also be represented as phi x of omega. So phi x of j omega is equal to e power j omega into mu x minus omega square into sigma x square divided by 2. So this is about the Gaussian random variable x. It's a probability density function, it's a characteristic function. Another variable y is also Gaussian. So another Gaussian random variable y is considered with the mean mu y, variance sigma y square. Now obtain the characteristic function of the sum x plus y. Sum of two Gaussian random variables x and y, x plus y taken as w. Then obtain the characteristic function of w, the sum w equal to x plus y for 0 mean and variance sigma x square as 2, sigma y square equal to 4. You have to get the characteristic function of the sum first, then the characteristic function of the sum when the mean mu x and mu y are zeros and the variance sigma x square is equal to 2, sigma y square is 4. First we'll find the characteristic function of the sum w. Characteristic, since x is a Gaussian random variable, characteristic function of x, phi x of j omega is e power j omega mu x minus omega square sigma x square by 2. Similarly, the characteristic function of the Gaussian random variable y, phi y of j omega will be equal to e power j omega mu y minus omega square sigma y square divided by 2. So we have the characteristic function of x, phi x of j omega, characteristic function of y, phi y of j omega. Now w is equal to x plus y, the characteristic function of this sum, characteristic function of w denoted as phi w of j omega is given by phi omega of j omega is equal to, if you see this in the first module, then it is same as phi x of j omega into phi y of j omega. If you see the theoretical part of Gaussian bivariate Gaussian random variable, there it is proved. Each of these characteristic function, you have to see the first module, how we get that characteristic function of Gaussian random variable. When we consider the sum of two random variables, two independent random variables, then the Gaussian characteristic function of the sum, characteristic function of the sum w, phi w of j omega is the same as phi x of j omega into phi y of j omega. Characteristic function of the sum will be product of the characteristic functions. Both are known, e power j omega mu x minus omega square sigma x square by 2 into e power j omega mu y minus omega square sigma y square by 2. Base are same, powers can be added. E power j omega mu x plus j omega mu y, which will be j omega into mu x plus mu y. Then minus omega square sigma x square minus omega square sigma y square, omega square into sigma x square plus sigma y square. While adding these two powers, common denominator LCM is 2 divided by 2. So this is the characteristic function of the sum W. Now in the second part it is asked, find the characteristic function of the sum W when the mean are zeros, mu x and mu y are equal to 0. Variance sigma x square is equal to 2, sigma y square is equal to 4. So look at this characteristic function of the sum W, phi w of j omega. In that you put means mu x and mu y as zeros, variance sigma x square as 2, sigma y square as 4. It will be e power j omega into 0 minus omega square into 2 plus 4, 6 divided by 2. So it will be e power 0, ignore it, minus 6 omega square by 2 e power 6 omega square by 2 means minus omega square into 6, that is minus 6 omega square by 2, which will be minus 3 omega square. Characteristic function of the sum W, sum of two independent Gaussian random variables. So this completes the topic, bivariate Gaussian random variable and sum of two independent random variables. In the next lecture video, we shall see independent and identically distributed random variables. Here we have seen independent random variables. Next topic will be independent and identically distributed random variables. Thank you.